Welcome back. We're going to continue our discussion on acid-base equilibrium, and the equations that I had given you earlier, just to simply determine pH and pOH, they would also continue into this newer topic because, it's not that much different. But how we calculate the component like this or this is going to be different. Once we calculate them, we put them into this equation to get pH or pOH. Okay? So the foundational equations would stay the same. But how we approach and get these H3O plus or OH minus will be different, and that's kind of how equilibrium works. All right. Now, what is one unique feature about a weak acid or base that's convincingly different than a strong acid or a base? And in fact, the difference is weak acid, okay, or base, okay, the reactions themselves, okay, reactions do not go to 100% completion. And which is why, see, when you have a strong acid plus strong base, we use the straight arrow, right? And we said we get salt and water as a product, right? Whereas when we have a weak acid and a strong base, or weak base and a strong acid, typically, weak acid, weak base combination, the reaction is very slow, that we rarely consider it, it's not going to work. But these two combinations are going to be primarily our folk interest, whether weak acid reacting with a strong base or a weak base reacting with strong acid. We use double-headed arrow. You can ask me, hey, there's a strong component in one of those, each of those pairs. No, they both have to be strong for it to be a single-headed arrow. If one of them is weak, then you get a double-headed arrow. This is 100% completion. When you have a single-headed arrow, means the reaction is complete and it's not happening. Whereas when your reaction involves a weak acid or a weak base, if one of them is weak, then the reaction is only going to 50% completion. Okay, this is very similar to, say, you unlock the cap on your water tub in your bathroom and you let water run. If you let it run at a certain rate, you see that if you turn it really, really fast, then yeah, you're gonna not have all the water drain. But if you adjust the flow of water in such a way that every drop that hits the bottom of the tub gets flushed out through the opening on the tub. So that's how a weak acid, strong base, or weak base, strong acid works. It's just 50% completion. Then whatever hits goes out. So whatever product made, so you go from reactant to a product, and the product goes back to reactants. This cycle keeps happening if one of them is weak, which is why we say there's a 50% completion when it comes to a weak acid or strong base. And obviously the arrows themselves, whenever you have a weak acid or weak base, or weak acid and weak base, you have a 50% completion and you have a double-headed arrow. Whereas when you have strong acids and strong bases, you have a single-headed arrow. This goes to 100% completion, this goes to 50% completion. All right, there are three statements I'd like to point out. Now, these are not statements that are given in a book. These are statements I created because this is where people just lose their brain and try to do weird things. Okay, so keep these in mind. You don't need to memorize this. I am not going to quiz you on these three statements. These are just to find out that these are where areas you would continue to confuse yourself, and I don't want you to confuse yourself, so this is just kind of a statement to stop you from getting confused. Okay, now if you remember in the lab or the exercise leading into the lab, I gave you a value for pH. I did not say whether it was belong to an acid base, none of that. I gave you a physical value alone, okay? Starting now, that will change, okay? You will always see a concentration and the name of the acid or the formula of the acid or the base. From the concentration, you will find the pH or the POH. You won't be directly given pH or POH, okay? That is the right way, but the reason we did that is for you to get used to using a calculator and actually understand the idea of pH and POH and how they are interrelated, okay? Can I always determine pH and POH for any acid or base given the molar concentration? The answer is no. Only for strong acids and bases, if you're given a concentration, you can use the concentration itself to determine pH or POH. We're going to do some examples. Now again, pay attention here. Only for strong acids and bases, which means I will obviously trick you given the molar concentration of a weak acid or base and have you find pH and POH. If you use the value directly, you're going to get an answer, which is not what I'm looking for. So statement 1, answer is no. Statement 2, if one of your product, since we are going to get into the world of weak acids and weak bases, okay, let's say you have a reaction and you end up with one of your product is always going to be H3O+, and if that's the case, that's acidic. The reaction is acidic, which means you can only determine pH. From pH, you can determine POH. So this is the only route possible, okay? The reverse is not possible if your reaction is acidic. Similarly, if one of your product is OH-, that means the reaction is basic. That means you would have to first determine POH and then pH. The reverse is not possible. You cannot determine pH directly for this. There are, using the formulas you can, but I would say that it's a little confusing. So I'd rather have you find one and then use 14 to get the other, all right? So keep in mind, if one of your product is this, your reaction is acidic. If one of this is this, then your reaction is basic. So this is what, when we did your vinegar, orange juice, this is what was happening. So that's vinegar, orange juice, or your whatever, so coffee. That's what was happening. Whereas basic, we did your ammonia, bleach, and stuff like that, and your blood. Obviously not blood, but you could have used your spit. In that case, this would have been basic, right? So you can only determine one and find the other, okay? Which you determine depends on the nature of the reaction, and I want to make that very clear. And H3O plus is also interchangeably known as H plus. So H3O plus is same as H plus, which is known as proton. So you finish Chem 170, 175, and if someone asks you, hey, what's the formula for proton? This, or hydronium ion, which is also equated to proton, but this is the formula for proton. But be prepared, we will interchangeably use this. They both mean the same, all right? This is not going to be something difficult, but I want you to get used to it because I will be doing that, and anybody you watch will also do that. So just get ready for that, all right? So statement 1 will be applied immediately in the next video. Statement 2 will be applied in successive videos. Statement 3 is just for you to know that when I start using H plus in place of H3O plus, or the other way around, what I'm meaning is the same. The meaning does not change. Okay, now these are not statements that are typically not available in the book like this. So if you're going to flip through your book, you're not going to find statements like these. Okay, I've compiled them so it's easy for you to understand the concept. All right, with that said, I'm going to see you back with how to calculate pH and POH of strong acids and bases, so we can actually compare to what we are interested in learning, which is pH and POH of weak acids and bases. this. All right, so stay tuned.